Alright, so we're now dealing with the November 2017 a question that a student asked me one of the days. I said, let me put it up because it's a nice question. It's different from some of the other ones that have came out. Okay. So partial fractions, it could be around 6 or 7 marks. Okay. So here, first thing we check is the numerator of a lower degree than the denominator. So the highest power in the numerator is 2, highest power in the denominator 4, so it satisfies the condition for us to go and apply partial fractions. Okay, so now what we need to do is we need to factorize this denominator. So let's write that down. We need to factorize fully. Right, before we go and apply partial fractions. So now, let's take our denominator. So the denominator here is x to the power 4 plus x. So if I want to factorize this, step number 1 is take out a common factor. Alright, so if I take out x as a common factor, what am I left with? I'm left with x to the power 3 because x times x cubed will be x to the power 4 plus x times 1 is going to equal to x. Right. Now we got x to the power 3 plus 1. So here what we have is this part here. This is called the sum of two cubes. It's called the sum of two cubes. So we need to remember, go back to our M3 one, and we must remember how to factorize the sum of two cubes. So here we have, let's say we have A cubed plus B cubed. So that is the sum of two cubes. And then when we factorize here, it will be a plus b, and then it's going to be a squared. Our middle term is minus ab, and our last term is b squared. Right. So here, so what I'm going to do now is, this one can be written as 1 cubed. So that's x cubed plus 1 cubed. So now here my x will be a and my b will be 1. So I will factorize this. Well, let me do it right here. So this is going to be x plus 1, and this will be x squared. So there's my a squared, which is x squared. The middle term will be minus x times 1, which is x. And the last term will be plus b squared, that will be 1. Right, so I have to factorize fully. Now, let's go and deal with our partial fractions. Right, so this is the step, the very crucial step that if you forgot the sum of two cubes, you are going to get stuck. You weren't going to work it out. Right, so let's take these partial fractions. Let's write it out. So what do I have here now? I have 2x squared plus 2x minus 5 all over x times x plus 1 times x squared minus x plus 1 is equal to. Alright, so here, let's see, I got 1, 2, 3 factors here, but remember the highest power there is 4, so I need 4 constants, a, b, c, and d. So that will be a over x plus b all over x plus 1. Now, this part here, this is your quadratic. That cannot be factorized. into prime factors. So this is a quadratic that cannot be factorized. So remember, it cannot be factorized, it's a quadratic, so there's 2. And you have the power 2, so you need 2 constants here. So this is going to be x squared minus x plus 1. So if I already have a and b, I need c and d. So that's going to be cx plus d. So now I have all my fractions, and now I can do the usual. And so what am I going to do next? I am going to rewrite, I'm going to get rid of all the denominators. So let me write it down here. So now I have 2x squared plus 2x minus 5. So how did I do this? What am I doing now? I'm going to multiply by this factorized denominator on both sides. So these denominators will cancel. Now remember, I'm going to multiply by x times x plus 1 times x squared minus x plus 1 by every single term. It's pointless going and actually writing it down. You can see what is going to cancel there. Right, so we have a. So now what will happen? X will cancel with x. So I end up with x plus 1 times x squared minus x plus 1. Then my next one there is plus b. So what will happen here? X plus 1 will cancel with x plus 1. So I'm going to be left with x times x squared minus x plus 1. And then I have plus cx plus d. So what's going to happen here is x squared minus x plus 1 will cancel there, and then I'm going to be left with x times x plus 1. Now we need to find the values of a, b, c, and d. So what can we do? We can substitute values for x, and let's see what can we substitute values for x that's going to get us to our solution as fast as possible. I mean the solution, I mean a, b, c, and d. Or you might have to use both methods, equating coefficients and substitution. Okay, so clearly I can say that I can substitute 0. If I substitute a 0, how do I know that I need to substitute 0? Because x is a factor, and if I replace x with 0, 0 times anything here will be 0, 0 times anything there will be 0, then I'll be able to work out the value of a. Then I can also substitute negative 1. Why? Because negative 1 plus 1, I know this whole thing will be a 0. This will be a 0 because it's x plus 1. And then I'll be able to work out the value of b. Okay, so let me do that quickly. So let me start with let x equal to 0. So if I let x equal to 0 on the left hand side, I'm going to end up with minus 5 there. Here, if I put a 0, that's a 0, that's a 0, that's a 0. So we're left with 1 and 1. So 1 times 1 is 1 times a, which is a. This is a 0, that's a 0. Straight, I got my answer for a. You can see that. Then the next substitution, let x equal to minus 1. So if I substitute a negative 1 now, let's see what will happen here. So that will be negative 1 squared, which is 1 times 2, which is 2. And then minus 1 times 2 is minus 2. So I've got a 2 minus 2, which is 0. So left hand side I have minus 5. Sorry? Oh, sorry, my mistake there. That is a minus there. Sorry, my mistake there. Okay, so the 2 was negative. I copied it down as positive. So there's a negative there. So it did not affect the first one. Okay, did not affect my first constant. but it does affect the next one. Right, so if I put a minus 1 here, minus 1 squared is 1 times minus 2 is minus 2. And then minus 2 times minus 1 is minus 2 again. So minus 2 is minus 4. Minus 5 will give me minus 9. Okay. Now, what am I looking for? I'm looking for the x plus 1. Wherever I say x plus 1, I know it's going to be 0. Why? Because minus 1 plus 1 is 0. So I'm going to have a 0 there. I will have a 0 there. So this is what I need to work out. Okay, so minus 1 squared is 1. Minus minus, so that will be 1 plus 1 there, which is 2. Plus 1, which is 3. And 3 times the minus 1, which is minus 3, so that will be minus 3b. Okay. So therefore, minus 9 divided by minus 3 is equal to b. So therefore, b is equal to 3. Alright, so now we got a, we have b. Now we need to work out the values of c and d. Okay, so I started off with substitution. We can still continue with our substitution there. Or if you want to use equating coefficients, you can. But let me just do this, because if I use substitution, I'll be still left with 2 unknowns. And I can use simultaneous equations to work it out. Okay, but we have to do this fast in the exam. Okay, so now let me put another substitution here. Let x equal to, let's put 1. 1 is an easy number to substitute. Okay, so I've got minus 2 plus 2 minus 5. So I'm going to have minus 5 there. Now I'm substituting 1. Remember that. So 1 plus 1 is 2 there. 1 minus 1 is 0. And that's a 1. So that's a 2 times a. So that will be 2a. Okay, here 1 squared is 1. Minus 1 is 0. 0 plus 1 is 1. This is also a 1. So it's just plus b. Here 1 plus 1 will give me 2. That's a 1. 2 times 1 is 2. And then I got 1 times c, which is c. So that's c plus d times 2. So that's going to be plus 2c plus 2d. Now, I already know the values of a and b. So let's substitute that. So I just worked out a, which was minus 5, and my b was 3. So let's see what will happen here. So 2 times minus 5 is minus 10. Minus 10 plus 3 is minus 7. So if I take it to the left, it will become a positive 7 minus 5, so I get 2. So 2 is equal to 2c plus 2d. Okay, I've got an equation in terms of c and d. I can divide by 2 here. So 1 is equal to c. Plus, you don't have to do it at the moment, but clearly you can see that 2 is common there. You can take it out. So now I substituted 1, 2, 3 times. Remember, it's 4th degree, so I need to do 4 substitutions. So one more time. Let me do one more substitution. So let me do it on the top. So I'll say let x equal to, let me go for 2 this time. Okay, choosing the smallest numbers that we can. So let x equal to 2. So let's go to the left hand side here. You can double check on the calculator. So 2 squared is 4 times minus 2 is minus 8. And then 2 times 2 here is 4. So minus 8 plus 4 is minus 4. Minus 5 will give me minus 9. So I've got minus 9 on the left hand side. So I'm choosing, remember, 2. So 2 squared is 4 minus 2, which is 2 plus 1, which is 3. So I know this is a 3 here. And 2 plus 1 is 3. So 3 times 3 will give me 9. So that will be 9a. So I know this whole thing here is 3. I just worked it out here. 4 minus 2 plus 1. So that's 3 times 2b will be 6b. Here, 2 plus 1 is 3. And this is a 2. So 3 times 2 is 6. And this is a 2c. So this whole thing here is 6 times 2c will be 12c, and the 6 times d will be 6d. Right, now we know the values of a and b, so let's do the substitution. The value of a is minus 5. The value of b is 3. Okay. So now what do we get? So we need to just take all this to the left hand side there. So we get minus 45, and then we get plus 18 there. Take it to the left hand side. Give me the answer there quickly. Fast, like you've been sitting in the exam. So 12c plus 6d is equal to, what do we get on the left hand side? What do we get? Use the calculator. Fast.
It's 18.
18, straight. Okay. Positive 18. Alright, so now, what can we do here? We can divide if we want to. But basically we have two equations now. Here's your one equation here. That's one, and this is the second equation. So you can use the method of substitution or elimination, it's up to you, or Kramer's rule to work this out. Let's see what we can do. If I divide by 6, let's divide this whole thing here by 6. If I divide by 6, then I'm going to have d here. I'm going to have 12 divided by 6, that will be 2c, and 18 divided by 6 is 3. So I've got 3 is equal to 2c plus d, and then I've got 1 is equal to c plus d. So what I'm going to use is the method of elimination. So I'm going to go top minus bottom, d minus d, 0 straight, 2c minus c is c, 3 minus 1 is 2, so c is equal to 2. Fast, you get your solution there, you can see that. Now I'll take this and substitute it here, so 1 is equal to 2 plus d, so therefore d is equal to negative 1. Right, so that was the main thing to do there, to find the values of a, b, c, and d. Now, what are we going to do? We need to substitute back into the formula there. Into our fractions. So what do we have? Minus 2x squared plus 2x minus 5. So we got over x. This is x plus 1. And that is okay, so let's do the substitution quickly. My a is minus 5. B was, where is the b value there? 3. C is 1. No, C is 2. And then D is minus 1. Right, so we substituted everything. Now, what do you notice here? Okay, these ones you should be able to do it straight in your head. Even this one, now look at it. This is a quadratic. Normally we have to complete the square and use inverse tan. But in this exam question, the values above, if you look at it, you got a 2x. Look in the bottom, that you have x squared. The derivative of x squared is 2x. derivative of minus x is minus 1. So we have exact derivative for every single one. So what do I mean? We have this situation here. K f prime x on the top. There's my f prime x here on the top. And there's my f of x in the bottom. So the answer is going to be k ln f of x plus c by inspection. There's no need to use new substitution. Right, so remember this minus 5 over x. I forgot to write down, there's a dx there, there's a dx there. So what you need to do is always take your constants. So there's a minus 5, write it in front here, and that becomes 1 over x. There's your 3 here, take your 3, write it in front, it becomes 1 over x plus 1. So now every single fraction satisfies this condition here. The derivative of x is 1, exact derivative there. The derivative of x again, 1, exact derivative. Derivative of x squared minus x is 2x minus 1. So everything is f prime x over f of x. So we go straight to our solution. So the answer is going to be minus 5 ln absolute value of x there. This is going to be plus 3 ln absolute value of x plus 1. And then you have plus ln absolute value of x squared minus x plus 1 plus c. So this was from the November 2017, according to a student that gave me the question. Right, so we did not have to use inverse tan.